Welcome to myprojectbazaar.com. Let's discuss about the product. Our product is a look-ahead clock gating based on auto-gated flip-flops. Clock gating methodology is used for power consumption in overall the circuit. It is not only used in the flip-flop circuit. The clock gating is a general concept. We can adopt that with any logic circuits. Commonly, there are three gating methods. So, among the synthesis-based approaches is commonly popular one, and the second method is called data-driving method. This is the complex implementation and which has the complex design methodology. And the final one, that is the third method, is auto-gated flip-flops. That is what we are going to implement in this process. This performs huge amount of power consumption. So that's why we are concentrating on auto-gated flip-flops. So the low-power flip-flops design featuring an explicit typic pulse triggering structure and a modified triggering and single-phase clock latch based on the signal feed-through scheme is presented. The presented design successfully solves the long discharging path and it also reduces the power consumption. Flip-flops are the basic storage elements used extensively in all kinds of digital designs. In particular, digital designs nowadays often adopt intense pipelining techniques and employs many flip-flop rich modules such as registers, files, shift registers and filing first in, first out. It is also estimated that the power consumption of the clock system, which consists of the clock distribution networks and storage elements, is all high as 50% of the total system power. Flip-flops thus contribute a significant portion of the chip area and power consumption to the overall system design. So the pulse triggering, that is what is one of the single latch structure is most popular than the conventional transmission gate, that is TG, and master slave flip-flops in high speed applications. Besides the speed advantages, it is circuit complexity lowers the power consumption of the clock tree systems. A flip-flop consists of a pulse generator for strobe signals and a latch for data storage. If the triggering pulses are sufficient narrow, the latch acts like a edge trigger flip-flop, since only latch as opposed to two in the conventional master-slave configuration is needed. A flip-flop is simpler in circuit complexity. This leads to higher toggle rate for high-speed operations. In this brief, we are designing a flip-flop based on auto-gated flip-flop design. So our goal is to obtain the better and to reduce the power consumption of the circuit. So let's see the flow of our process. So this is the overall designing methodologies shown by the black diagram. So according to the description, we are designing based on the CMOS design methodology. For that we have to use Tanner EDA tool for the implementation. So basically we all know about the Tanner EDA, that's based on CMOS designing tool. So initially after selecting the CMOS designing methodology used CMOS, we have to design the flip-flop design, and in the flip-flop design we have to adopt the clock gating methodology, that means auto-gated flip-flop. So while we are applying auto-gated methodology in flip-flop, that becomes an auto-gated flip-flop mechanism. So according by this enhancement of auto-gated, we can obtain the power consumption by the simulated results, and we can verify that by the parameters which we simulated, and we can analyze this and we can compare with the existing methods. Let's discuss something about the tool. For this CMOS design based methodologies, we have to use CMOS design tool, that is called Tanner EDA tools. Commonly, Tanner EDA tools having lot of subdivisions, that is called SEdit, LEdit, WEdit and such more. There are lot of under devices. So in this we are using SEdit for circuit designing. So and then after we design that SEdit, while simulating, the circuit's design will pass through the T-space that we can understand through the checklist generated through the spice code. And finally, while we are simulating, the timing diagrams will appear in WEdit. Hence, commonly for our CMOS based designs, we will use mostly these three edit things. That is, again I will say as SEdit, LEdit, WEdit and T-Space. So we can design the circuit based CMOS transistors by using SEdit. Here, before we starting the simulation, we have to select a new cell. Here is a cell menu. Here we have to select the cell menu and we have to select new cell. So there you can select number of cells like cell 0, cell 1 up to cell n you can select. So each cell should contain different CMOS design. And next process is to set up simulation. Here this icon, while you are pressing that will leads you to setup simulation. In the setup simulation you have to set up maximum time duration for the design and nanoseconds based setup methodologies. After designing setup designs, we have to load the library files. So initially for the design of CMOS designs we need some CMOS components. Those CMOS components will occupy in CMOS libraries. That means CMOS libraries contains components of which required for CMOS design. So here you can see what are the components listed in CMOS library. While you are pressing add, it will leads you a window menu. There you can locate the library file where you have stored. So from the location where you have stored, you can select all components which you can need for your CMOS design. So after design of this cell, you can save the design, and while you are pressing run, it will leads to T-Space. So through T-Space you can see what are the checklist available in T-Space. In T-Space usually the components which you have used are listed in as a component code. That means you can see that as a program wise. That's why that T-Space codes are called netlist. You can run either from SEdit or from T-Edit. From wherever you are running, the output timing diagrams will show in WEdit. In WEdit you can see the waveforms which we have obtained for corresponding CMOS design. And also you can clarify what are the result parameters, and you can measure all the parameters which you need for the design from the WEdit. Thank you.